Alright, so here's another redox balancing example. It's one of the reactions shown in problem 20.25 in the book. And it's the reaction between molecular iodine, I2 solid, with hypochlorite, the active ingredient in household bleach, to form the iodide anion and chloride. And this is done under acidic conditions. So the first thing we need to do is to assign oxidation numbers to everything so we can see what's being oxidized and what's being reduced. Start with the easy ones. The oxidation number of any element in its natural form is just 0, which takes care of I2. The next easiest ones, the oxidation number of any element that is a monoatomic ion is equal to that charge, which means the oxidation number of chlorine in chloride is -1. We'll do OCl minus next. Oxygen, when it's part of the compound, is going to be -2, or almost always -2, and is in this case. The oxidation numbers of everything has to add up to the overall charge, which means that the chlorine atom in OCl has to have an oxidation number of +1. And last but not least, we'll do the iodide anion. Again, the oxygen is going to be -2 in this compound. There are 3 of them, so we sort of have a total of -6 contributing from the oxygens. The overall oxidation numbers has to add up to -1, the overall charge, which means we have to have +5 here, and since that is distributed over just one single iodine atom, the oxidation number of the iodine atom in I2 is going to be +5. So we need to split this up into oxidation and reduction half reactions, and there you can get that by looking at the elements for which the oxidation number changed. So the iodine went from 0 in I2 to +5 in IO3, so that's the oxidation half reaction. I'll just write that here. So we have I2 solid becoming iodate, IO3 minus aqueous. And on the reduction side, we have chlorine going from +1 in OCl minus to -1 in chloride. Alright, and we'll just tackle each one of these one by one. So, the first thing you need to do is balance anything that's not hydrogen or oxygen by inspection, just make it work. So in this case, we need to double up on the iodates because we have 2 iodine atoms here. The next step, and for the reduction half reaction, the only element there is chlorine, and that's already balanced. Next step, balance the oxygens, and we do that by adding water to the side that needs it. So we need 6 oxygen atoms to balance out the 6 in the IO3. So I'm just going to add 6 waters there. So now the oxygen's balanced. And we need to add 1 oxygen atom there. The next step is to balance the hydrogen atoms by adding protons to whatever side needs it. So we added 12 hydrogen atoms here in the water, so we need to add 12 protons on that side to balance that out. And likewise, we need two protons here to balance those out. So at this point, all of these 2 half reactions should be atom balanced, and check. So 2 iodines, 12 hydrogens, 6 oxygens, 1 chlorine, 1 oxygen, 2 hydrogens, 2 hydrogens. They are probably not, however, charge balanced. And so what we need to do here is to add electrons to the more positively charged side of each half reaction to get those to balance out. So we have an overall charge of +10 on the product side here. Everything is neutral on the reactant side, so we would need to add 10 electrons to get that to balance out to, actually we'll add electrons on the product side of the oxidation half reaction. On the reduction half reaction, we have -1 on this side, +2 on this side. So we have to add 2 electrons to get that to -1 on each side. Now also check, the electron should be a product in the oxidation half reaction and a reactant in the reduction half reaction. If they're both on the same side, you made a mistake somewhere. The next step is just to multiply these half reactions by whatever factor you need to get the electrons to cancel out. In other words, in this case, what is the least common multiple of 2 and 10, which in this case happens to be 10. So you don't need, so the appropriate factor for this one is just 1. So I'll write this out and space it a little bit better. So we have solid I2 with 6 liquid waters, giving you 10 electrons, 2 aqueous iodates, and 12 aqueous protons. Now, everything on the reduction half reaction side needs to be multiplied by 5, which will give us 10 electrons, 5 hydrochlorites, aqueous protons, 5 aqueous chlorides, and 5 water molecules. So again, check to make sure that in this case the electrons should balance. We've got 10 on each side, so we're good. The next step is just to combine these reactions back together again. So we'll put all the products together, all the reactants together. So we're going to have solid I2 plus 6 waters plus 10 electrons plus 5 hypochlorite ions plus 10 protons, giving us 10 electrons, 2 iodates, 12 protons, 5 chlorides, and 5 waters. Now, the last thing you want to do is clean up anything that's on the same side. Now, the electrons need to cancel out. You can't have any electrons showing in the original, in the overall equation. And next, look at the waters. So we've got 5 waters here, 6 waters on the reactant side, so we can cancel those 5 out. This would just become 1. And we also can cancel out some protons. We have 12 here, and 12 here, 10 here, so those 10 can cancel, and then this will just become 2. And then that is all the cancellation we can do, so clean that up. So we have I2 solid reacting with 1 water molecule and 5 hypochlorites to give you 2 iodates, 2 protons, and 5 chloride ions, and that's balanced.